Hello my dear students, once again welcome back to your online class. So I have already sent you an introductory video telling you my names and the subjects that I will be taking in your class. But once again let me introduce myself to you. My name is Deepak Chetri and I will be taking physics and chemistry in your class. So in this first video we will be discussing on the first chapter of your physics and as well as chemistry also. Because if you look into your book you will find the first chapter in physics and chemistry is the same and the chapter's name is matter. Okay, so now coming to the chapter and talking about the matter. So what is a matter? So matter is anything that has a weight or that occupies a space or that can be perceived by our senses. So hence we can say that almost everything we see around is a matter. Okay, like, and sometimes even the things we cannot see, that is also a matter. For example, air around us, we cannot see air, but still air is a matter. Then comes a point or a question, then what is not a matter? So like many things that does not occupy a space, that does not has a weight or which cannot be perceived by our senses, they are not a matter. For example, your anger or your happiness or our emotions, our feelings, since it does not occupy any space, neither it has a weight, so it is not a matter. So the first important topic in this chapter is about the states of matter. Okay, so talking about the states of matter, there are three states of matter. Okay, so namely what are they? They are the solid, liquid and the gas. Okay, so it is solid, liquid and the gas. So example of each of these you must be knowing. Solid, like a chalk I have here, the mobile phone you are holding, it's a solid. The liquid, you must have seen water, petrol, kerosene, diesel, so all of them they are liquid. And gases, though we do not see it, but we know that we are surrounded by gas like oxygen, carbon dioxide, nitrogen, so all of them they are gases. Okay, so now coming to the common properties of all of these state of matter, the common property is all of these, irrespective of its state, whether solid, liquid or gas, they are made up of a minute particle known as atoms. So then what is the difference? The difference is just about the arrangement of those particles. Like in solid, if I consider a solid, in solid the molecules are very tightly packed, very tightly packed, almost no space between the two molecules or the atoms. If you come to the liquid, these molecules are loosely packed compared to that of the solid. And if you come to the gas, in this the molecules are very loosely packed, okay, and they are free to move in any direction or they move randomly. So if you are asked to write the difference between the solid, liquid and gas in terms of the molecular concept or the molecular theory, so the first thing you can write is the solid. In solid, the molecules are very tightly packed. In liquid, it is loosely packed compared to the solid, but in gases, it's very loosely packed. The another difference you can say is, like here you see, almost there is no distance between the two molecules, and the distance between the two molecules is known as intermolecular space. Okay, so here the intermolecular space almost negligible. There is no intermolecular space in case of solid. In case of solid, there is a slight greater intermolecular space compared to that of the solid, and in gas the intermolecular space is very large. Now coming to the attraction between the two molecules. Okay, so the two molecules or the two atoms, they are very close to one another, so hence the force of attraction between the two molecules is very large. Okay, so and that force is said to be the intermolecular force of attraction. So in case of solid, the intermolecular force of attraction is large, here less, and there the intermolecular space is least. Okay, so in that way you can easily write the difference between the solid, liquid and gas in terms of its molecular arrangement. So whether solid, liquid or gas, there are common properties among its constituent, that is the molecules, and that is known as the kinetic theory of matter. So if you are asked to write the kinetic theory of matter, so remember that kinetic theory, or it's also called the postulate of matter. Okay, so you will be writing it the point wise. Like the first one, what did we see? We see that whether it is solid, liquid or gas, all of them, they are made out of a small particle known as atoms or molecules. The second, you can write that all of them, they are always in the state of random motion. Okay, and they do not move in a definite direction. So if they are moving, they move in any direction. That is a random motion. And the third one, you can write that with the increase in the temperature, this molecular motion also increases. The fourth one, you can write that the space between these molecules, it is known as a intermolecular space. The sixth, you can write that the force of attraction or repulsion between each of these molecules or atoms, it is known as intermolecular force of attraction or the repulsion. So that is the kinetic theory of matter, or we can also say the postulates of kinetic theory of matter. Now coming to the interconversion of state. Okay, so the other important topic is the interconversion. Interconversion of state. Okay, so interconversion, it means changing from one state to the another. So if you are asked define the interconversion of a state, so simple, it is the changing of a matter from one state to the another is known as a interconversion of matter. For example, you can take the example of ice, like if you put a water into the refrigerator in the freezing chamber. So what happens? That liquid, it changes into solid, and then if you take that solid or the ice cube out of the refrigerator, slowly it will change into liquid, and if you take that liquid and boil it, what happens? It changes into gas. Okay, so there are 6 different steps that involves in the intermolecular state, interconversion of state. So that is, so when we change solid to liquid, what is that known as? We call it as a melting. Okay, so during melting, the heat is absorbed. So we can define the melting is a process in which the solid changes into the liquid by the absorption of heat. Now if you heat liquid, what happens? It changes into gas, and that is called boiling. Okay, so if you are asked to define the process of boiling, we can simply define the boiling is a process in which the liquid changes into the gaseous state by the absorption of heat. Now you must have seen when you cover a boiling water, on the lid there are some water droplets. Actually what's happening? That steam or the gaseous state is changing back into the liquid, and that is said to be the condensation. So now if you are asked to define the process of condensation, it's very simple. The condensation is a process in which the gas changes into the liquid by evolving heat. Okay, so boiling, it absorbs, and in condensation it evolves heat. And finally one more we have. So liquid, if you freeze it or if you put in a refrigerator, it changes into the solid, and that process is known as freezing. Okay, so what is the freezing now? The freezing is the process in which the liquid changes into the solid state by evolving heat. Okay, so these are the 4 main processes involved in the interconversion of state. Now apart from these main 4, there is 2 more interconversion. Like usually what happens, the solid changes to liquid, but there is a process in which the solid directly changes into the gas, and that process is known as sublimation. Okay, so what is sublimation now? The sublimation is a process in which the solid directly changes into the gases without passing through the liquid phase is known as a sublimation. For example, if you take if you take a naphthalene ball, you know naphthalene ball that we usually put in a cupboard to chase away the cockroaches and the insects. So what happens? Naphthalene ball, day by day its size decreases, but it does not change into the liquid. Then what's happening actually? The naphthalene ball, it's being converted into the gas, and that is said to be the sublimation. And there is a reverse process also in which the gas, it directly changes into the solid. For example, carbon dioxide. Okay, you must have not seen, but it's good for you to know that if you take a carbon dioxide and freeze it at a low temperature and a high pressure, instead of changing into the liquid carbon dioxide, it directly changes into the solid, and that process is known as deposition, or it's also known as desublimation. So desublimation is a process in which the gas, it directly changes into the solid without passing through the liquid state. So example is the carbon dioxide gas, and that ice or the solid form of the dry carbon dioxide is said to be the dry ice. Okay, so this is very important from your examination point of view. So remember what is the interconversion of state and all these 6 processes involved in the interconversion of state. Now apart from this interconversion of state, there is one more term known as evaporation. Okay, so what is evaporation now? The evaporation is also the process in which the liquid changes into the gaseous state. Okay, but what is the difference between, so here the boiling is also the same. The boiling is also the liquid changing into the gas. Evaporation is also the liquid changing into the gas. Then what is the difference? The boiling, it takes place at a constant temperature, at a definite temperature. Like the water, it boils only at 100 degree centigrade. Below 100 degree, the water does not boil. But evaporation, it occurs at any temperature. For example, like if you wash your clothes, the wet clothes, okay, so we do not have to heat it to 100 degrees centigrade to dry it. We see that within an hour or two, what happens? The liquid present in the water, it vaporizes, okay, and that is because of evaporation, not because of boiling. So the evaporation is a process in which the liquid changes into the gaseous state at any temperature. So the effect of evaporation is it causes a cooling effect, but whereas the boiling, it does not causes a cooling effect. Like when we run or when we do a difficult task, we sweat. Okay, so when our body is fully covered with sweat and when we sit under a fan, what happens? Our sweat dries out. Actually, it's evaporating. When it evaporates, what happens? We feel cooler. Okay, so the evaporation, what does it do? It generates a cooling effect. Now there are some factors on which the rate of evaporation depends. Like for example, so first factor, let us write the first factor. So first one is the surface area. Okay, so surface area of a body. The larger is the surface area, the greater is the rate of evaporation. For example, if you wet a cloth and if you jumble it up, and if you spray it, which one will dry faster? The one which is sprayed out. Or for example, the tea, if you keep it in a cup, or the same tea if you pour out in a plate. So you will observe that the tea in a plate, it dries out faster because there the surface area is large. So the first factor is the surface area. Second, it depends upon the temperature. So very easy. Higher is the temperature, the greater will be the rate of evaporation, because during a hot sunny day, the clothes dries faster. The third factor, it also depends upon the speed of wind. Okay, so on a windy day, the clothes dry faster because the speed of wind is much more faster during those times. And it also depends upon the humidity. Okay, so what is the humidity now? You must have learned in geography as well. The humidity is the presence of water vapor in the atmosphere is known as humidity. So if there is already water vapor, it takes a longer time for the liquid to evaporate. So higher humidity means the rate of evaporation will be low. So basically there are 4 factors on which the rate of evaporation depends, namely the surface area, temperature, wind and humidity. So these topics are covered in your physics, and in chemistry you have one more topic, that is the conservation of mass. Okay, so that topic, so let us discuss conservation of mass. So what does this say? The conservation of mass says that we can neither create a mass nor can we destroy a mass. So in case of a chemical reaction, like when 2 substances are reacting to produce the third substances, then this law says that the sum of the reactant must be equal to the, like the weight of the sum of the reactant must be equal to the weight of the product. Like if I am reacting the 2 of the product, like if I am reacting A plus B, if it gives me C and D, C plus D. Okay, so if this weights M1 kg, this weights M2 kg, this weights M3 and this weights M4. So what does this law says? This law says the sum of the reactant, the weight of the sum of the reactant must be equal to the weight of the sum of product. That means M1 plus M2 must be equals to M3 plus M4. So that is what is meant by the conservation of masses. So if you are asked to state the conservation of mass, you will simply write, it states that the sum of the weight of the product, reactant will always be equal to the sum of the weight of the product. So that is what the law of conservation of mass conveys us. So this first chapter is very simple for you to understand, but still if you have any problem, you are always free to ask me through WhatsApp. And also it will be much more better if you go through your textbook once, twice or even thrice also, and then you try to solve those optional questions and question answers. And still if you have any problems, you are always free to ask me in my WhatsApp number. Thank you.